Hello and welcome to another tutorial in CS 4010, the structural dynamics and finite element analysis. In this short tutorial, I'm going to guide you how to find the natural frequencies of a structure. I will take the bridge I designed in the last tutorial as an example. Now, to find the natural frequency, you need a new model. It's called Modal. Alright, so please drag this component onto the static structure at the model and release. So now you can see that some data will be linked between the two models of the ANSYS. And all of this one has been grayed out. That means they has been imported. And if you want to change anything, you have to click on Setup, or you can double click on the model over here. So here is the bridge you have from the static structural A5, and because we try to determine the natural frequency, so therefore we go to model B5, and they are parallel to A5, so therefore you have to define everything you have here. So for the model B5, I have to define the fixed support. So I click on fixed support, I choose vertex, and I hold Ctrl for the multiple selections. Alright, and then I just click on Applied. Now I have declared this one. The only thing I need to change is the analysis setting. I can keep the default max mode to 5, or I can change it to the number I want. For example, I have it here maybe 10. And then I can start solving it. So now it has been solved, and you can click on solution to see the natural frequency of your structure from the lowest to the highest. And if you want to have visualization, you can select the frequency you are interested in, and then right click, and then do the create mode shape results. So in here, all of the vibration mode has been created, but it has been inserted after solution, so therefore you have to re-evaluate all of them. So right click and evaluate on result. Yep, so you can see here will be the vibration mode of your structure. Now let's have a look at the first mode, and it is logical, because you know that if you have the frame like that, it should be a rectangle frame, so therefore it doesn't have side support. So the easiest way is sway side to side like this one, and the frequency for this one is 2.7. so it's quite dangerous, I guess, because it's close to the frequency of people step. It's about 2 Hertz, 2 steps per second. And it can cause a resonance between the step and the vibration of structure. Now let's have a look at the next one. So when we the mode 2, so it's still the sideways vibrations of the steel frame, but now it's half bridge, and because it's shorter, so therefore it can be faster. It's almost double the frequencies of the structure. When you look at the mode 3, so you can see that this is the vibrations of a few at the middle, a few elements. And as I told you in the lectures, most of the vibrations are the combination of other element vibrations, so it is understandable. Now when you go to the mode 4, you will see something different. Now you have the participants of the concrete slab. It could be something like that, because you lack of the support right here, so therefore it has higher chance to vibrate up and down. And similarly to the mode 5, it will be on the other side. So you can see that for the mode 4 and mode 5, the frequency are very close. You can see that your range of frequency here is from 2 to 6, and they all fall into the dangerous frequency range for vehicle, which is about from half Hertz to about 30 Hertz. It depends on kind of traffic you have. So the main purpose of designing is to help your structure avoid the range of the dangerous frequencies. And in case you cannot avoid the range, you have to add up some dampeners or shock absorbers to help it reduce the vibration.